In this lesson, we're going to take a look at magnetic fields and how we produce them. And so the first way we produce a magnetic field is with a permanent magnet. A permanent magnet is made out of some kind of usually metal or ceramic alloy, and it's got its electrons all aligned so they spin the same direction, and magnets always have a north and a south pole. It's not like a charge where we can have just a plus or just a minus. A magnetic monopole has never been observed. They're theorized, not observed. Magnetic field lines follow some of the same behaviors of electric field lines. We said an electric field line emanates from a positive and terminates on a negative. Well, with a magnetic field line, they emanate from the north pole and terminate on the south pole. So they leave the north, they enter the south. If we look at iron filings and how they align when we put them around a magnet, we will see that a bar magnet produces magnetic field lines that look sort of like this. And just like electric field lines don't cross, we tend to think of magnetic field lines as not crossing. If we were to bring another magnet up next to this, we would see one of two different things. So if this is our north pole and this is a south pole, we would get a uniform magnetic field between these. Of course, we'd get a little bulging at the edges, just like in an electric field. If it was a north to north or south to south, so let's say I go north here and north here, then of course these field lines are going to be pushed away from each other, much like bringing light charges next to each other. Their field lines don't cross. They are going to do something like that. Permanent magnets are one thing. Then we have what you guys looked at in the second part of the lab, which was when we took a coil of wire, which is called a solenoid, and you wrapped it all around, and then nothing until you pass current through it. So we put a magnet down here and we were actually able to measure that this thing produces a magnetic field. And that's because moving charge produces a magnetic field. Okay? And so we noticed that iron can be magnetic. That's about the only metal that we tested that was. Nickel and cobalt can be as well. But when we start moving electric charges around, those also produce a magnetic field. Now there is a simple right-hand rule for determining which way the magnetic field is produced in a coil, in a solenoid. If you hold your right hand and you wrap your fingers around the coil in the direction the current is flowing, your thumb will point in the direction of the north pole of the magnet. So in this case, it looks like the current in the back is going that way, and so the current in the front is coming this way, and so like this, I would say that the north pole is up. If I reverse the flow of the current, then I would wrap my fingers the other way, and then the north pole would be this direction. So the right-hand rule for the coils, or a solenoid, an electromagnet, if you will, wrap your fingers of your right hand in the direction of the current, and then your thumb will point in the direction of the north of the magnetic field.